Hello and welcome to Michelle's videos. So today I'm looking at circle theorems, which is higher tier only. Higher tier only. Okay, so let me turn off my camera and share my screen with you. Share, and we'll get straight into it. But first of all, I want to show you this. Okay, these are your 7 main ones, and I'm just going to quickly explain them because you've got time to watch the video again. The angle at the center is twice the angle at the circumference. So if this was 120 at the center, then at the circumference the angle will be half. And if this was, I don't know, let's say if this was 50, then this would be 100. Yeah. The angle in a semicircle is 90 degrees. So here's a semicircle. It's cut it in half, totally in half, through the center. So the angle here is always 90 degrees, always. Okay. And we're going to put these into practice. Angles subtended by the same arc make the same arc, are equal. So this angle here and this angle here make an arc. So they would be, if one was 12, the other would be 12. And this angle here and this angle here make an arc. So if this was 6, this one would be 6. Opposite angles in a cyclic quadrilateral sum up to 180. I think that that's prior knowledge. So if this angle was, I don't know, 100, then this one would be 80. Yeah, prior knowledge. Tangents from a point are equal, so they make, if you put a line there, they make an isosceles triangle. Now this one is very much connected to that one. So radius, where the tangent meets the radius, is always 90 degrees. And we can see that here, look, 90 degrees, because it meets the radius there, and it meets it there. And that would make it right, an isosceles triangle, the base is the same. Angles in alternate segments are equal. So here's your triangle. So you've got a segment 1 here, and that is separated by segment 2 here. So if this angle was 50, the opposite one will be 50, will be equal. Now this is probably the hardest one. Let's do another one. Let's do this. Let's say that, and then you've got that and that, and your angle here was 10. So there's one segment. Let me change the color. There's one segment there, the biggie. And then there's another here. So opposite, follow the line, la 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 la. So your alternate angle would be 10. Probably the hardest, but we will try and look at it in more detail as we go along. Okay. But what I'm going to do in class is print this off blank. So you've got these 7 rules, okay, to keep looking at, because once you get used to them, they do become quite easy. I've also got a link that I'm going to send to those higher learners, whereby you can watch Corbett maths videos, and they're really, really good, really, really good. Okay, so that's a quick explanation. I'm now going to answer about 13, 14 questions using these rules. Okay, I'm going to use red. Right, so tangent meets radius at 90 degrees. Tangent meets radius at 90 degrees. Okay, so again, angles in a triangle, I'm putting my reasons down, equal 180. So 180 minus 90 plus the 72. So 180 minus 162 equals 18 degrees. BA, angle A, middle letter, is 18 degrees. Reason. Right, okay. This one, the center, the angle at the center is twice the angle at the circumference. So here's the center. Here's the angle at the circumference. Yeah, kind of opposite it. So 66 divided by 2 equals 33 degrees. So I've given my reason, and I've shown my working out. Equals 33 degrees. Right, number 3. Tangents that meet at the same point are equal. I'm just going to join them up. I don't know why. If I do. BAC, BA, middle letter. That is 40, which is nice. So, okay, tangent meets radius at 90 degrees. It's because I've got 2 of them. 1, 2. So, and angles in a quadrilateral. I'm going to say quad in future. Angles in a quadrilateral equal 360. So I've got 360 minus 90 plus 90 plus the 40. So I've got 360 minus 180 to 20. So that equals 140 degrees. That must be there 140 degrees. So BOC, BO, number, I found it. Okay, I'm just going to change my color just to show you something here. If we had something, I don't know, like that now, yeah, we could find that angle because it'd be 70 because twice center. Yeah, so you can start building up and looking at it like that. Right, let's have a look. Okay, this is the Now, if you forget, look at your sheet of paper, okay? This is the arc one. So let's just change my color to that. So this one and this one make an arc, and this one and this one make an arc, because I need to find one of them, I'm sure. A, C, D. A, C, B. So it's, sorry, I said D. A, C, B. A, C, B. So my middle number, I've got to find C. So they make an arc. That one. It's got to be 51. And that one will be 62. But that's the one I wanted. Okay. Right. Give a reason for your answer. So angles on the same arc are equal. And that's my reason. What you could do is go A, D, B is equal to A, C, D as well. Yeah. A, D, B is 51, and that is equal to A, C, B. Right. But you've got to mention arc. Right. Number 5. I can see a cyclic quadrilateral. So a cyclic means touching random sides. So that will be 83. That will be up 83. They're not equal. It adds up to 180. So that will be. So let's write the reasons. Angles in a cyclic quad. Remember, it's quadrilateral, but I'm shortening it. Add up to 180 degrees. So I'm going to show my working out. What does it want? A, B, C. A, B, middle number, wants B. So 180 minus 83 equals 97 degrees. So that's going to be 97 degrees. And then if we wanted to find A, C, we'd do 180, take away 94, leaves 86. And all of them should add up to 360. So we're applying it. Okay. 2 radii will be equal. They will make 2 radius, which we actually say radii, if there's 2 of them. So 1 radius, 2 radii. That's weird, but we can say 2 radius. It doesn't matter. 2 radius make an isosceles triangle, and the base is the same angles. So the base, the bottom, that will be 48 degrees. Right, next one. So we're kind of just applying it. Oh gosh, oh gosh. Oh gosh, this looks a bit complicated, but let's use our rules. 2 tangents from the same point are equal. So two tangents, so that's equal. And look at this, we've got two and they meet at 90. So we've got a few rules here. I'm going to write them down. Tangent meets radius at 90 degrees. Got isosceles triangle, right? Okay. So here I've got an isosceles triangle here, and I've got a quad here. Now what we're looking for, A, B, C is 46. We know that. OAC, so we're looking for A. We're looking for A, so we're looking for that bit there. We're looking for that tiny, tiny bit there. Okay, that's what we're looking for. Right, I have to do some adding up here. Righty, oh, so that's got to be the same as that. That is that. I could work out the isosceles triangle. So, okay, two tangents at the same point are equal. So these are equal. Okay, I could do this. So that would be 23, and that would be 23. OAC, we're looking for OAC. That's 90, 113. 90 plus the 23, 180 minus 113, because I could find that angle, which will leave me 67. So I could find that is 67, and then that would be 67, which gives me 57. No, divided by, yeah, sorry, leaves me 67. Brilliant. Then that's 67, that will be 67. So 67 plus 67 equals 4,834, which leaves me 620. 180 minus 130. I'm not doing my calculations very good here. Which leaves me 46. 46. It's an isosceles. Divide by 2. So that's going to be 23 degrees. So again, you're using quite a lot of information there. I've shown my working out. It may be messy, but I've shown it. Okay. You could have just done, you could have just maybe did not have that line there at all, and you could work it out as long as you can remember the rules. Yeah, isosceles, 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 because you've got two triangles there. Okay, rightio. So it really just depends how you go about it, but these are your important bits. Okay, give your reasons. Give reasons for each stage of your working out. We're going to go neater when we do this in class. This is just an example, okay? We're going neater with these. Oh my gosh, what's this? Okay, this looks even more complicated. Find the size of angle AC. So I want this angle here. Actually, pretty easy. Pretty easy, I think. Tangent meets radius. Tangent meets radius at 90. Let's put my reason. Tangent meets radius at 90. Well, I've just got that, haven't I? So 90 minus 76. Leave me and let me do this right now. 14 degrees. Okay, so that's looks difficult. Use your rules. Right. Find the size of ABC. Give reasons for your stage of work in ABC. Oh. I'm going to let you have a go at that. You're going to find that angle there. Use your rule. Use your rules. Okay. I'm going to kind of say to you, look at this 76. Look at this segment. Sorry, my dogs are barking. Sorry, my dogs are barking. Sorry about that. It was the postman. Right. Okay. So where was I? Yeah. So look at your segment here. Oh, I'm doing a rubber. Don't want that. I wanted a highlighter. Will it let me do a highlighter? Let's do green. Yeah. Look at your segment here. And look at your segment here. We can easily go back to the first bit. I don't want to give you too much. I want you to have a go at that because it is one of the hardest. So have a go on your own on that one. See what you come up with. Let me know in class, yeah. Right, next one. Oh my gosh, see, oh my gosh. Okay, I think we're going to have quite a lot here. So number 9. Okay, let's do what I know. I know that, and I know that, so I'm happy with that. So let's write that down. Tangent meets, even if that's all I knew, I might get a mark. Tangent meets radius. Know what you know. Try what you think you know, and just guess what you don't. Tangent meets radius at 90 degrees. So we know that the center, we know. I'm going to write it down. So the center is the center angle. I like to put angle is twice the angle at the circumference. So I know that as well, but I don't know that yet. I do know that they are, equal. And I know that, so 2 tangents from the same point are equal. And I do know that a quadrilateral equals 180 degrees. Right, I know all that. So what am I trying to find? A. So I've got to find this here. Yeah. So, okay. Well, I've got this. 2 tangents in a row equal quad equals 180. 180. 360, sorry. Right, so 360 minus what we got. 90 plus 90 plus 26. Now be careful, because haven't you got a 26 there as well? Good. Plus 26. So that's going to equal, again, we would do this neater in class, but it doesn't matter where it is, as long as you know what you're doing. So 360 minus, right, 180 plus 52, 180, 232. So that leaves me 8 to 128. I'm just going to double check. 2, 3, 2, 1, 2, 8, because I like to. That's 10, 6, and 3. Yeah, brilliant. Okay, 128. So this here is 128. Yeah, but that's here and here. So the center angle. So that's 128. We could split it. I don't need to, because I got that. So the center angle is twice the angle. So the center angle. So I'm going to put it here. 128 divided by 2 equals 64. 64, 128, yeah. So that answer is 64. So we had a lot going on there, but everything you know it all. Yeah. Right, let's have a look at our next one. Oh, okay. I'm going to be a bit crafty here. I can see that a radius there. I can see that. Okay. Shall I let you go about that? Ah, wait there. Wait there. I've got 2 radius now. Makes a isosceles 2 radius. 2 radii radius make an isosceles triangle. So the base angles are equal. Yay. So I kind of know that this angle here is going to be 29. Now I can work out quite a lot, because I know that tangent meets radius at 90 degrees. So 90 degrees. I can now work out that, and I'm sure you can. So have a go. I think it's quite simple now. Angles in a triangle, blah, blah, blah. Angles in a triangle equal, I don't know, you tell me. Okay, so sometimes you can put lines in to help you. Right, okay, that's number 10. Right, what we got? Like an alternate. Ah ha 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 ha. Ha 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 ha. Just said that. Right, find the value of x. Well, I'm thinking about my rules, and I'm thinking, oh, come on, let me do it there. I'm thinking that's one segment. And this is another segment. Let's just pull it in. Right, I'm also thinking I've got a triangle in that segment. So if I can find this one here, this segment 1 is opposite, x is opposite this. That's what I'm thinking. So angles in a triangle equal 180. And I've got 180 minus 61 plus 73. 180 minus 134. Okay, so that will leave me that will leave me 46 degrees. 46 degrees. So x, I'm going to write it, alternate angles, segment, sorry, segment, oh, it won't fit in, segment angles are equal. So x equals 46 degrees. And that's your answer. So nice alternate one there. Maybe you can highlight, you can take excuse me, you can take highlighters. So maybe use your highlighters for alternate segment angles. Have we got another one? Whoa, okay. What we've got here, now I'm going to let you have a go because we've kind of done that, we've done this, we've done that. Alternate angle, I think, because of your sector, I'm just going to highlight that for you. I'm just going to do that. At some point, I'm definitely going to be using that and that. Okay. Now, what I'm going to do here is I'm going to say the things you might need to know. Alternate segment angles. You might need to know about the isosceles triangle. What do you know about that? Angles in a triangle, you're definitely going to need to know angles in a triangle. And I think you might need center is center angle is twice the angle at the circumference. Use your paper, go back, watch the video again, go back, okay? Because you can, this is quite easy, believe it or not. So, which ones of them are you going to use to find the angle O? Think, 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 think. Good luck. We'll go over it in class. Right, there's two rules that have been missed. So I'm going to go to Corbett Maths here. And you can have a go at these, by the way. You know what I mean? But I'm going to go straight to question 13. Here. Now, it looks complicated, but it's really not. You've got a we haven't used the semicircle rule. I'm just going to change my colour. We've got a semicircle. So that will be 90 degrees. Yeah, the angle in a semicircle equals 90 degrees. So we can easily work out quite a lot now. Oh, I can see 2 radius here. So equal. So that has to be 40, and so on. Okay. What we're looking for, A, O, A. What we're looking for? Can't even see it. CAD. Oh, look, quite a few. Right. So that's all I'm going to give you. That is it. Right. You will use other rules. Write the rules down that you're going to use. Okay. Please write them down. And then you answer. You answer all of them. Find the size CAD. Give a reason, please. Find the size of ACB. Give a reason, please. Find the size of BCD. Give a reason. Again, bring it into class, okay? And we can go over it. And then the last rule, which is the same rule, but it looks different. 20, it's on 20. You can have a go all of these, you know. No, it wasn't 20. It wasn't question 20. Let's see if I can find it. Or shall I just draw it myself? Right, I'm going to have to draw it myself. So let's go on to my Word document. This one here. This one here could look different. Okay, I call it the arrow, but it could look very similar to this one. So let me give you an example. Right, so here's a circle, as good a circle as you're going to get anyway. There's a radius, straight line. I'm just doing this roughly. There's our center, and we've got a radius going down there. We've got that, that, and that. That is actually the same shape as that. It's just been twisted. So here is your center. So if your center was 58, this angle here would be 29. Okay. The way to think like about it is that shape there. Oh, let me get my pen. Again, my circle, lovely. Not very good at drawing, you know this. You're kind of getting the gist, right? But I'm not great at drawing, you know that. Actually, let's go back to that. This shape here, I'm not great at drawing, is the same shape because it's not touching the arcs, right? And that's what kind of what I was trying to say. Look, this is touching and making an arc. This isn't. It isn't making an arc. This one and this one are not making an arc. So it's the center rule. The angle at the center is twice the angle at the excuse me, at the circumference. So just be a little bit wary of that. Okay, my drawing is rubbish, but hopefully it gives you a demonstration of that. Right, come back to Teams. Turn my camera back on. Stop recording.